Today topic is linearity and superposition theorem. Here in superposition theorem and linearity conditions, a circuit containing independent sources, comma dependent sources and resistors is linear. Therefore, the system of equation describing the circuit is linear. So here independent and dependent sources and the resistance is linear. Automatically we say that equation of describing the circuit is linear. Here next one is the dependent sources are assumed to be linear. Example, if we have current controlled voltage source with V is equal to A AC square plus B, so the resulting system will be no longer linear. Why here the square is present, so for so square is present in this V is equal to AC square plus B, so it will be no longer occur the linear system. So for a linear system we can apply the principle of superposition theorem, that means superposition. So here in this context of circuits, superposition enables us to consider the independent sources one at a time. So compute the desired quantity of interest in each case and get the net results by adding the individual contributions. So here simply if the circuit is containing more than two sources or many sources, so first we considered one source at a time, remaining sources are completed disconnect or the source is switch off. So each cases, consider each cases and calculate, then after that all cases add the, so individual contributions will get the results. So no causation is superposition cannot be applied to dependent sources. It is only applicable for the independent sources. It is applicable for the independent sources. Now go for next one. The superposition refers to superposition of response due to independent source only. So we can consider one independent source at a time, deactivate all other independent sources. If for example we have the many sources in the circuit, only we should be consider only independent sources at a time. After remaining sources, all remaining sources are remaining sources, so it will be deactivate other independent sources. So now next deactivating a current source, that is 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 equal to 0, replace the current source with an open circuit. When the current is 0, so when current is 0 is nothing but that is OC. So OC means here, so the current source is open circuit, here with open circuit. When the source is voltage source, if the source is applied voltage source, deactivating the voltage source, Vs is equal to 0. That means here when the voltage is 0, when short circuit is occurred, then voltage will be 0. So Vs is equal to 0 is replace the voltage source with a short circuit. So here see one example, so very important one example has given in this figure. So here the 18 volts and 2 ohms and 4 ohms and 3 amps. Here the two sources are given. One is the voltage source, another one is the current source is 3 amps. So 18 volts is the voltage and 3 amps is the amps. So this is the sources are given. So next one. So here case 1, take the case 1. In case 1, so here Vs is kept same as it is where it is the circuit, So 18 volts, 2 ohms are in series, and deactivated the current sources 3 amps. Here, this is the 3 amps is the current source. It is denoted by the arrow within the circle. So here the current it is the current source, so it can deactivated, that means it is open circuited. So current source is open circuited. Then we calculate the current in the 4 ohms resistance I1. So now next one is, so here, see here, 18 volts are applied to the 2 ohms and 4 ohms. That is nothing but 18 by 6, which gives the current I1 is equal to, so how much, 18 by 6, that means 3 amps. 3 amps I1 dash here taken as a I1 dash. Why I1 dash here? Here the source, first source is case 1 is taken as I1 dash, case 2 is taken as I2 dash. So here the current direction is 4 ohms in upward to downward direction. So here the voltage is applied across 2 ohms and 4 ohms, so will gives the, so I1 dash is 3 amps from the voltage source for case 1. Now, so here I1 dash is 3 amps from the case 1. Just you remember that from the case 1, 18 volts applied, the current I1 dash is 3 amps. So now in second case, go for second case, here the 18 volts, that means 18 volts are short circuited, and that means it is deactivated. Deactivated means Vs is short circuited and keep Is same as it is. So 3 amps and 4 ohms and 2 ohms. So in case 2, so I1 double I1 dash 2. So here case 1 I1 notation 1 power. So here I1 2. Here we will get the I1 power here 2. In case 2, current will get the 1 amp. In case 1, we got I1 dash is 3 amps, and case 2 current is 1 amps. So both currents are in same direction. So it is upward to downward direction in 4 ohms resistance. So see here, observe this one, I1 in case 1 is upward to downward, and same in the case 2 also upward to downward. So here, so both currents are in same direction, so these individual currents are adding, we get the resultant current, that is, so I net I1 is equal net, so I1 from the case 1, I2 from the I1 double or 2 from the case 1. So I1 is 3 amps from the case 1 is 3 amps, and so case 2 is 1 amps, so we'll get the 4 amps. So this is the superposition theorem. What says the superposition theorem here? So the individual, take the any one, the individual sources is considered in the circuit. If you want to go for a superposition theorem, only consider at a time one source, and remaining sources are deactivated. Then each one is considered as a source and take the values and calculate. So after that, individual values are add, then we'll get the resultant value. So it is current or voltage, whatever the. So now next here, so example, another example is 12 volts 6 amps. Here a dependent voltage source has given, here dependent voltage source has given, so the current is I, is the current is I 12 volts 6 amps 3 ohms, and independent, two independent voltage source is 2I, so that is given. So now go for here in case 1, see here, observe what they did. Case 1, the current source is deactivated and Vs is as it is, same as it is. So now, so here write the equation and get the current value. So how can we write this equation? See here, we get the value of current. So KVL, write the equation of KVL. So here minus 12, so plus 3i plus 2i plus I, which gives that equal to 0, KVL loop equation. So I is equal to, we'll get the 2 amps, then V is equal to here. So V is equal to 6 volts. Where 6 volts? Where 6 volts? At 3 ohms. At 3 ohms, we will get the 6 volts. So that is the voltage V. So here voltage V is considered at the 3 ohms is 6 volts in the case of 1. In the case 1, so keep VSC as it is and deactivate the IS. That means here it is a open circuited. So now see here, observe this one, the case 2. So keep IS is as it is and deactivate VS. So VS deactivate means short circuit the 12 volts. The voltage source is short circuited here. So see from the circuit diagram. So current I in 1 ohms, voltage across the 3 ohms V, and the voltage dependent voltage sources. So 2I and the current is source is 6 amps. So now so write the equation and we'll get the, so here by writing of KVL equation, so I into 1 in the 1 ohm, the 1 ohm the voltage drop is 1 into I, so we will get the I in 3 ohms, the 6 amps and the I amps is adding in 3 ohms, so so written in this way, plus 6 plus I into 3. So here the current is, so here in the voltage the dependent sources, the voltage is 2I. So by this equation, KVL equation, will get I is equal to minus 3 amps. Now voltage across the 3 ohms is, now what is that? The current 6 plus I into 3. So what is the current here? Minus 3 amps. So 6 plus minus 3 will get the 3, and that into 3, that is equal to 9 volts. So here 9 volts as so taken in the case 2. So at case 2 keep IS is and deactivate VS from the 6 volts and 6 volts and here to 9 volts. How it is? So it is the individual response, the case 1 and case 2, how we will get. See here in case 1 from the voltage is 6 and the current from the case 2 the voltage is 9 volts. So both these 2 volts are the same, the current direction is same, so we'll get the adding cases. So here case 1 and case 2 voltages are both are added, so 6 plus 9, that is equal to 15 volts. So this is the old example for in to finding the voltage in the superposition theorem. So now, so superposition theorem, so here superposition theorem, see here, here superposition theorem, so they written, so see observe here, supply voltage and the current is and R1, R2 and R3. Here the KCL at nodes is given. At node A and B, they written in this way. At node A, they written V1 minus Vs by R1 plus V1 by R2 plus V1 minus V2 by R3 that equal to 0. This is the node A. At node A, once again I shall repeat here. So V1 minus Vs divided by R1 plus V1 by R2 plus V1 minus V2 by R3 that equal to 0. This is across the node or junction at a point. Now at point B or junction is, so see here, so V1 is at node A and V2 is node at B. So now minus Is plus V2 minus V1 by R3 equal to 0. Here minus Is is nothing but a opposite direction. So minus Is plus V2 minus V1 by R3 that equal to 0. This is the KCL at equation by writing in matrix. So what does it mean? G1 is equal to 1 by R1, G2 is equal to 1 by R2, G3 is equal to 1 by R3. So right in this way we can write so in different way. So here we will get the matrix equation. So they have given the matrix manner. So now next go for another example. Here superposition theorem, find out the current through R2. So now circuit has given in this way. So 10 volts and 5 volts and 100 ohms, 100 ohms, 100 ohms. So now here from this circuit we can calculate the value of so whatever the current or voltage. So sorry, in this case find the current through R2. In superposition theorem, see here, observe this, so 5 volts, this 5 volts is replaced by the short circuit Vs2. Here see this one replaced is short circuit, this is short circuited Vs1 10 volts and the R1 100 volts and R3 100 volts, R2 is volts, and here the V2 5 volts is replaced Vs2 with a short circuit. So solution is step 1 is replace Vs2 with a short and find the current through R2 due to voltage source Vs1. So from the circuit here they has given, so R3 and R2 are both are in parallel. So we'll get the equation one, will get the, so 100 parallel, that means here the current resultant resistance is the 50 ohms, and this 50 ohms and 100 ohms are both are in series, so we'll get the 150 ohms. Now the current is, so IT, so S1 Vs1 by RTS1 10 volts 150 ohms will give the 67 point milliamps. So from the source 1 the current is 67 point milliamps, and here the 66 point milliamps is divided into two parts in 100 ohms 100 ohms. That means here the I2 is half of the total current. Here half of the 33.3 milliamps. Here we'll get the I2 is 33.3 amps from the source 1. The note that this current is downward through R2 from the higher to lower through. So now go for the next one, next source, the superposition theorem. So here from the superposition theorem, the source one is deactivated, means source one is short circuited. That means here replace VS1 with a short circuit wire. So see, VS2 is as it is same. So now from this, so finally the RST is the same. RT of S2 is the same 150 ohms, and RT is so half of the. So here we can, by calculating this, IT total current is 33.3. So in this R2 is we'll get the half of the 33.3 in R2. So current is I2 is we'll get the 33.3 by 2. So that means 16.7 milliamps. So note that here the current is downward through R2. The current is downward through R2. So in previous case, step 1 will get the 33.3 amps, and here in step 2 we got the 16.7 milliamps. From these two we can add, will get the resultant current. So here both component currents are downward through R2, so they have the same algebraic sign, so same direction. So therefore add the values to get the total current through R2. I2 is equal to I2 of S1 plus I2 S2 33.3 milliamps plus 16.7 milliamps will get 50 milliamps. This is the example for the superposition theorem. So now another example, find the current through R2 in the circuit. Superposition theorem. So find the current through R2 in the circuit. So now the 10 volts is the voltage source, and 100 milliamps is the current source, and determine the current in the R2. So same. So here deactivate any one source is replaced by the short circuit or open circuit. If the voltage is so deactivate, then it will be short circuit. The R current is deactivated, that means it is open circuit. Now in this case, in step 1 the current is open circuit, so the current is deactivated, that means it is open circuit. Now total current is, when the current is deactivated here, and the current is deactivated here, so there is no current, that means Is is equal to 0. That means Vs is applied to the 220 volts and 100 ohms. We'll get the resultant current I2. At step 1 I2 is equal to 10 volts divided by 320 ohms. Here that will get, we get so 31.2 milliamps. That is the step 1 case I2 current from the downward direction, ground direction. So here the current is so note that this current is downward through R2. How much? 31.2 milliamps. Now from the case 2, so replace Vs with a short. So replace Vs with a short. So we'll get so short. Here Vs is 0, and only the activated circuit, present circuit is Is in the current. So the circuit is current Is is 100 milliamps. So now from this concept, the current 100 milliamps is divided into 220 ohms and 100 ohms. So now the Ia2 of S is R1 by R1 plus R2 into Is, that means 220 by 320 will get the 100 milliamps, will get 68.8 milliamps. Here note that this current is also downward through R2. So here by applying current divider we can get the current in the circuit of, so in the circuit in resistance R2. So here 68.8 is given, is calculated, and in previous 31.2 is calculated, but both currents are in the same direction through R2. So add them to get the total is 31.2 milliamps and 60.8 milliamps will give 100 milliamps. This is the current flowing through the I2. So here next one is another example problem. We can find the current through the 100 ohms resistor. So here two sources are present, two current sources. So what they are asking, find the current through the 100 ohm resistance. So in this circuit, two current sources are present. That means here deactivate any one source. Deactivate any one source. Here IS1 is a source 1 current and IS2 is a source 2 current. So now go for step 1. Here the current source 2, that means second current source is deactivated, that means it is 0. When the 0, the circuit is open circuit, there is no current in the circuit. So here the 10 amps from the source, one 10 milliamps is the current, whole current is flowing through the 100 ohms. So now this current is, so in the 100 ohms the current from the source one is 10 milliamps. So IS1 is 10 milliamps. Now go for step 2. Go for step 2. So deactivate the second circuit. In this circuit, see here, observe this one. The current is from the downward to upward from the second source in the 100 ohms. The second source current from the downward to upward 3 milliamps. So the same 3 milliamps is going to 100 ohms and 56 ohms. So it is downward to upward. So it is the direction of previous current direction, opposite. These two directions are opposite direction. So very very important. So upward through the 100 ohm resistance. From this concept, so first one is 10 milliamps, second one is 3 milliamps. So these both are in opposite direction. So we'll get the, so subtraction. So from the total, to get the total current through 100 ohms resistance, subtract the small current from the larger because they are in opposite direction. So the resulting total current is in the direction of the larger current from source IS1. So here I 100 ohms total is equal to I 100 ohm IS1 minus I 100 ohm IS2. So 10 milliamps minus 3 milliamps will get 7 milliamps. So the resultant current is downward through the resistor. So here, so resultant current is 7 milliamps. Now, so another problem, find the total current through R3. This is a simple circuit. They confused, but the simple circuit. Here 2 voltage sources are given. So R3, to find the current through R3. So same procedure, follow the same procedure, and here short the second one and activate the first one and deactivate second one. So here the current of, here replace VS2 with a short. So total resistance is 1.69. So R2 and R3 both are in parallel. So R2 and R3 are R2 R3 by R2 plus R3. This resultant is in series with the R1. So we'll get so finally 1.69 kilo ohms. So ITS1 VS1 by RTS1 will get 11.8 milliamps. 8 milliamps. The current through, so R3 is, by dividing this current is, will get, now apply the current divider formula to get the current through R3 due to VS1. So I3 of S1 R2 by R2 plus R3 ST1 will get the 1.0 kilo ohms by 3 kilo ohms, 11 point into 11.8 milliamps will get 3.69 milliamps. Notice that this current is downward through R3. So now go for case 2. In case 2, so here in case 2, source 1 is replaced with a short And so current, find I3 due to source Vs2 by replacing source Vs1 with a short looking from the Vs2. So now resultant current RT of S2. So same here, R1 and R3 both are parallel, so R1 R3 and parallel, so R1 R3 by R1 plus R3 will result give the in series with the R2, so will give 1.69. So IT of S2 is 8.88 milliamps, so V2 by RT total, so will give the 8.88 milliamps. So this is the current. Now go for current in I3. So I3 is nothing but R1 by R1 plus R3 IT of ST, which gives the 2.78 milliamps. This, notice that this current is upward through R3, upward through R3. So now next one is calculate the total current through R3. So I3 of total is I3 of this current calculate total current is, these are the, so in R3 in two directions and both are opposite direction currents, I3 of S1 minus I3 of S2. So these are the, so current are different directions, so we'll get the subtract 2. So 3.69 milliamps minus 2.78 milliamps will get 0.91 milliamps, that is equal to 910 microamps. This current is downward through R3. No. So superposition theorem is completed.